All right, we are on section 2.1. Woohoo, unit 2. Okay, where there's 8 chapters in this one. So last semester you only had 6 chapters. This is 8. So on to do. We have a lot to cover, as you can see in their little bullets here. Up first, we're going to talk about right triangles. So we're going to go back to geometry where you first learned SOHCAHTOA. Does that ring a bell? Sine, cosine, and tangent. So back in geometry, you learned that sine was your opposite over your hypotenuse. Cosine is your adjacent over your hypotenuse. Tangent is your opposite over your hypotenuse. I mean, opposite over your adjacent. So that's where your SOHCAHTOA. Y'all remember seeing this in your geometry class? Okay. My teacher taught it to us as some old hippie caught another hippie tripping on acid. And so that's how I learned it. But now what's new here is it's reciprocals, right? So the reciprocals are saying that instead of it being opposite over hypotenuse, for cosecant is now hypotenuse over opposite. Instead of it being opposite, adjacent over hypotenuse, for secant, it's now going to be hypotenuse over adjacent. Okay, for cotangent, it's now going to be adjacent over opposite. Does that sound doable? It's still just a reciprocal. Still what you learned with SOHCAHTOA. We're just now using its reciprocals. All right, let me know when y'all are ready. Okay, remember, if you don't get an opportunity, they are completely written also on your what's space. All right, so we're going to apply it, right? So we're going to find angles, all trig values for angles A and angle B. Yes, thank you. I was about to walk back there and I was like, this one. Adjacent means next to. So Lupe is opposite of you, but Astacia is adjacent. It's the angle, it's relationship to the angle. What do you mean? It's the side. So for example, we're looking at sine of A, and we're going to look for cosine of A and tan of A, right? So the sine of A, so from this angle, what's opposite of it? 7? Does that make sense? And this is automatically your what? Hypotenuse, because it's across from your 90-degree. So my opposite is 7. My hypotenuse is 25. So it's 7 over 25. Does that make sense? Okay, on cosine. So cosine of A is it's adjacent. So what's next to it? 24. And what's your hypotenuse? 25. So the cosine of A equals 24 over 25. Okay, tangent. So tangent of A is your opposite over your hypotenuse. And therefore we end up with 7 over 24. Still with me? Do you remember this from geometry? But now, is it doable though?
Can you re-go to the...
Yeah. So the first thing you're going to do is identify the angle. So my angle is A. Then you're going to identify your hypotenuse. Your hypotenuse is always across from your right angle. And then everything else is based off its relationship to A. So from A, this is its opposite. This is its adjacent. And now you're just following the rules. So sine of A is your opposite over your hypotenuse. My opposite is 7. My hypotenuse is 25. For cosine of A is adjacent over hypotenuse. My adjacent is 24. My hypotenuse is 25. And tangent is your opposite over your adjacent. My opposite was 7. My adjacent is 24. These are all simplified. So those are my final answers. Cool? All right. You're now gonna do, really quick, sine and cosine and tangent of B. So sine, cosine, and tangent of B. Oh, identify the angle, identify your hypotenuse. You'll never do CR. Not because we learned the sine of the feeling better about it?
Yes. I remember it now.
Now coming back, I'm like, I promise you, you learned it. We're gonna start off with what you should already have learned. Is that cool? All right, so this time we're focusing from angle B. So focusing from angle B, my opposite is 24, my adjacent is 7, and my hypotenuse is still 25. So you should have ended up with 24 over 25, 7 over 25, and 24 over 7. Yes? Yes. Doable? All right, geometry win. Yay. Okay. With that being said, I didn't put in the note for us to be able to do the reciprocals because I feel like we all understand too. But is that cool? Yeah. All right. All right, this is new, our co-function identity, okay? So we're on to co-function. For any acute angle, a co-function value of complementary angles are equal, okay? Remember, complementary means that it equals 90 degrees, right? The two angles equal 90 degrees. And supplementary is 180. The two angles equal 180. Okay. So when we have our co-function identities, it's saying that if it's an acute angle, so less than 90 degrees, then it has, these are rules that apply. So the sine of this angle equals also the cosine of said angle. Obtuse is greater than 90. Wait, yes. Yeah, greater than that. Wait. Yeah. Yeah, you make me think I'm crazy. I'm like, no, it's greater than 90. Oh, I walked over to get my pen and I still left it. Okay. All right. So, again, the key thing is for it to work, it has to be an acute angle, which means that the angle has to be less than 90. All right. So, I just remember it as sine and cosine go together, tan and cotangent, and secant and cosecant. But everything is going to be the same as far as 90 minus A, 90 minus A, 90 minus A. Yep. All right, the best thing to do is to apply it. So let me know when y'all are ready to apply it. All right. So up first, it says write each co-function in terms of it, each function in terms of its co-function. So the first thing you want to make sure is that the angle is less than 90 degrees, right? So checking first, is 52 less than 90 degrees? Yes. So to find its co-function, remember, cosine is going to always be with sine. So the co-function here is going to be sine of 90 minus 52. Which equals sine of, what's 90 minus 52? 38. And that's it. So what it's saying is if you were to type cosine of 52 in the calculator and sine of 38 in the calculator, their answers would be the same. Okay, using that same logic and what we just wrote down, what would tan of 71 be? There we go, cotangent. And we'll do 90 minus 71. which equals cotangent of, is it 19? And that would be its cofunction. All right, again, 24 is an acute little angle. What would be its cofunction? Cosecant. So we have cosecant of 90 minus 24, which equals cosecant of what? 66. How do you feel about being able to find the cofunction? Doable? All right, cool. It's all written out pretty. All right, here we go. It says find one solution for the equation. Assume all angles are acute angles. Okay. So in order for this to be true, what has to be true about these two angles? These two have to be complementary. Remember, in order for it to be true, the two angles are complementary. So they have to be complementary angles. I never know if I spelled this right, but I think I did. Complementary, which means that the angles have to equal 90 degrees. So if I'm trying to solve for theta, I know that theta plus 4 plus 3 theta plus 2 has to equal 90 degrees. Remember, in terms of trig, theta is just a variable. You treat it like an x. Because together they have to equal 90. They're less than 90, but together they have to, an acute is less than 90, but complementary means that they have to be equal to 90. Because the two acute angles equal 90. Does that make sense? Everything? Yeah, that's the only way you can make complementary angles. They have to be acute angles added together. All right, combining like terms. So I have 1 theta plus 3 theta is 4 theta. I have 4 plus 2 is 6. Okay, what do I need to do to get theta by itself? Subtract the 6, and we're left with 4 theta equals 84. And then what do I need to do? Divide by 4. So what would theta have to be? Theta would equal 21. So now can I fill in the full statement here? Because I now know the value of theta. I'll do this color. So this means that the cosine of what's 21 plus 4? 25 equals the sine of what's 3 times 21? Plus 2? 65.
Oh, okay.
What happened?
Is that 1 theta plus 4?
Yeah, 1 theta plus 4. Because it said theta, and I just want to make sure you knew that that meant there was 1 there. The imaginary Casper friendly 1. Okay. It's not terrible. It's not terrible. All we did was add, combine, do a little division. All right. I need to get to the next one. Yes. Okay, your turn. So here you have tan of 2 theta minus 118 theta equals cotangent. Because I have tan equal to cotangent of something, that lets me know that these are cofunctions and that these two have to do what? Equal 90. Go ahead and solve. Let me know if you need me. Say what? How'd you get 0? Oh, they just cancel out. Like I just crossed them out. Is that what you're asking? Okay, yeah, I just crossed them out. So you should have got theta equal 30. So what are the angles that make this a true statement? We have tan of 42 and equals cotangent of . Feel good about it? About cofunctions and solving equations with cofunctions? Okay, I picked that.
Really?
What was that?
Oh.
Which one? So we had theta equals 30, and then we on this one, we got theta 21, and then we plugged 21 in, and we got 25 and 65. All right, are we good with this part? What? I thought you wrote it. I don't know what you're doing. Can't see. All right, so we're going to be talking about increasing and decreasing a function. So what happens? So as you can see here, as A increases, so as the angle gets bigger, because there is a relationship, it's going to change how your Y's and your X's go, right? So as my A gets bigger, my R isn't changing. R is going to stay R. The radius stays the radius. But what happens to X and Y? They are affected, right? So here's my original function. If I get bigger, then that means Y gets bigger, but X is going to do what? Get smaller. The bigger the Y gets, the smaller the X gets. Does that make sense? And that's because R is fixed. So A increases. So when you look at it in terms of how is it going to affect the trig values, this is how it affects the trig value. So as your angle increases, because of the change in your Y and the change in your X, that means that sine overall is going to increase. Your cosine is going to decrease. Tangent is going to increase. And the reason why tan increases is because the Y is getting bigger than the X. And then your cosecant does the opposite of your sine. So if sine was increasing, then cosecant is going to decrease. If cosine was decreasing, then secant is going to increase. They're going to be opposite behaviors because their reciprocals are they're reciprocals. They're going to do opposite behaviors because they're reciprocated. So your power, your numerator, denominator is switching. Okay. The reason why this works is remembering the fact that sine of an angle equals Y over R. Cosine of an angle equals X over R. And tan of an angle equals Y over X. So if my numerator keeps getting bigger than my denominator, then that's an increase. Does that make sense? If my numerator is getting smaller than my denominator, then that's gonna be a decrease. And again, if my numerator grows, but my denominator gets smaller, then that's gonna be an increase. It's just numerically what's happening. Okay? So with that being said, you have to be able to make true or false statements. Okay, so keeping these in mind, we're gonna determine whether the statements are true or false. Got it? All right, so up first we have sine of 21 degrees and sine of 18 degrees. Which is bigger? I mean, is it true or false? It's true. Why is it true? Because your angle increased and therefore your sine will be also increased. So angle increase, so the sine is going to increase. All right. So we said right here, as the angle gets bigger, these are the things that happen. So if the sine of A increases, the cosine. So these are the rules that are followed, that are being stated. So when I look here, I have the sine of 21 degrees and the sine of 18. My angle got bigger, so therefore the sine is going to get bigger. Does that make sense? 18, well, 21 is bigger than 18, right? So since 21 is bigger than 18, then the sine of 21 is going to be bigger than 18. Because as the angle grows, your sine grows. Not an obvious, because cosine does the opposite. Okay, secant. So secant here. So secant, so for cosine, it decreases, but for secant, it's going to increase. So here, it's saying that the secant of 56 is less than the secant of 49. Is that true or false? It's going to be false because 56 is greater than 49. And because 56 is greater than 49, that means that my secant also is going to increase. If I said cosine of 21 is greater than the cosine of 18, this is a false statement. Okay, the reason why this is a false statement.
Okay.
Oh, I'm about to explain. I mean, the reason why it's a false statement is because as your angles increase, right? So 821, when my angle got bigger to 21, that means that my X value got smaller.
Yeah. Is that because of the thing you showed us, right? Okay.
So, right here, this is, so if I'm at 18, right? I'm at 18 and I grow to 21.
Okay.
As I grow to 21, my X value did what? It got smaller. So my cosine is gonna get smaller. So the cosine of 21 is less than the cosine of 18 because of the fact that my X value is decreasing. Is that not clicking? I don't know how to say
Okay,
it.
so then what about, if sine is Y, cosine is S?
Yeah, that's why when this was the sine of 18, the sine of 21, my Y value did what? It increased. That's why the sine of 21 is greater than the sine of 18.
Right.
Are we looking at the numerator or the denominator?
You're looking at the relationship between both.
Right, so then sine increases, Y increases.
Exactly.
Okay, and cosine increases.
As the angle increases, your X decreases, which is your cosine.
Okay. But what do I change it?
Tangent depends on your Y because Y is in the numerator of tangent. So when you look here, it's Y over X. So thinking about just fractions in general, if my numerator is getting bigger, then my number is getting bigger, right? If my numerator is getting smaller, then my number is getting smaller. So if this is getting larger, then the sign value is getting larger. If this is getting smaller, then what's happening here? The cosine value is going to get smaller.
So we can take the tangent and sine?
These are going to be the same because Y is their numerator.
Okay.
Okay,
Yeah.
so you're just watching how the numbers are changing to determine how that side, how it's gonna affect. And the reciprocals are the opposite. So on this one, you do. On this one, when we did secant of 56 compared to secant of 49, 56 is greater than 49, right? And because 56 is greater than 49, it's reciprocated. It's gonna be that this value is actually going to be secant because it's now the numerator, right? The denominator. So that number getting smaller means that my number,
Right.
it's the opposite.
I only have.
So secant is the opposite of
Right.
cosine. So now it's R over X. The smaller my X get, the less people I'm sharing my money with, right? So therefore, that's why it's getting bigger. I'm sharing with less people.
Yeah.
But it's also just generally the opposite. I'm reciprocating it. So if cosine means that it's decreasing, then secant means that it's increasing. So this is where that math and a lot of words in geometry come into play.
So, even that. So that's.
As the angle increases, your Y increases and your X decreases. Says it right there. Okay. So that's where the true and false statements come into play. All right, so you just got to be able to understand that relationship and be able to state whether it's true or false. So, yes. All right. We're going to talk about 30, 60, 90 triangles going back to geometry. Do you remember 30, 60, 90 triangles? Yes. Okay. Your 30, 60, 90 triangle comes from splitting an equilateral triangle in half. Okay. Yes. Any good geometry teacher would have made that connection. 30, 60, 90 comes from splitting your equilateral triangle in half. And so it creates two 30, 60, 90s. And that's what we're going to be talking about. Okay. Now you have, instead of an equilateral triangle, you now have two right triangles. Okay. Yes. All right. And now we're going to talk about the rules for right triangles. What happened? What? Oh, okay. So when you cut it in half, we always want to start with rules are based off the smallest possible number that something can be, correct? The smallest, if I'm wanting to have something, is 2. If I have 1, then I have to deal with the decimal, right? And do they want to deal with decimals? No. So that's why the original, they start off with saying this is a 2, 2, 2 equilateral triangle. When I cut it in half, it now becomes a right triangle with a measurement of 1, 2, and an unknown. Does that make sense? Okay, we're gonna use Pythagorean theorem to show what X is and then create our rules from there. Is that cool? All right, so here we are. We're gonna do the Pythagorean theorem to find out what is our leg that we do not know of our right triangle. Okay, so that ends up being x squared plus 1 squared equals 2 squared. All at a squared plus b squared equals c squared. Still with me? So that gives me x squared equals 4 minus 1. Yes? So therefore, x equals the square root of 3. Yeah? Okay. So now we know that x is the square root of 3. These numbers apply to all 30, 60, 90 triangles. Because all 30, 60, 90 triangles are just manipulations of this. Whether it's a increase in scale or decrease in scale, it's going to always be with the same ratio, 1 square root of 3, 2. Okay. So it's now, this is our ratio for all 30, 60, 90. Okay. Across from 30 is going to always be a ratio of 1. Across from 60 is going to always be a ratio of square root of 3. And across from 90 is going to always be a ratio of 2. These are your angles, and these are your sides. So 30, 60, 90, the ratio to the sides is gonna be 1, square root of 3, 2. And I should have used colons and not dashes. I apologize. So how does this help me? Well, this helps me because if I have a 30, 60, 90, as long as I'm given one side, I can find the measurement of all the sides because of this ratio. Cool. Okay. Key thing to remember, you may hear referred to as short, long, and hypotenuse. So this is my short side, this is my long side, and this is my hypotenuse. Remembering from geometry, your shortest side is across from your smallest angle. Okay. Now we're gonna talk about the 6 trig ratios of this. So now that I have all of my sides, can I talk about the ratios? So if I'm looking at 60, so using the angle 60, this is always gonna be my hypotenuse. This is now my opposite, and this is my adjacent. Can I easily identify sine, cosine, tangent, cosecant, secant, and cotangent? I surely can. So up first, we're gonna do sine, cosine, and tangent. So the sine of 60 degrees is what? Square root of 3 over 2. Great. What will be the cosine of 60? 1 over 2. You're so smart. Good job. And then what about the tan of 60? You see how and why Andrew set those numbers? Following what we've labeled? Yeah. All right, let's quickly do their reciprocals. Okay, so we're at cotangent and secant and cosecant. Again, it's all in perspective of angle 60. So here's its opposite, its hypotenuse, and its adjacent. Okay, so the cotangent of 60 is square root of 3 over. Good job. Okay, the reason being is that adjacent is 1. And its opposite is square root of 3, and you have to ratify. When I ratify, I'm multiplying the numerator and denominator. What I do? Probably for we got it at 50. Oh, no, not last one. Are the notes in front of you also? You can follow along on Brightspace. What is Okay, what is it? Secant of 60? 2 over 1, so it just becomes 2. What is the cosecant of 60? So 2 square root of 3 over 3, and that's because you have to do what? You gotta ratify. So you ended up with 2 over square root of 3, and we gotta multiply the numerator and the denominator by square root of 3. And that's all 6 of our 60. Now what I want you to do is to do the same thing for 30. Okay, so now you're gonna do 30. So you're gonna find the sine, the cosine, and the tangent, and the cosecant, and the secant, and the cotangent for 30 degrees. Good. All right.
No.
Oh, what happened?
No.
Okay, so let's talk about 30. Sine of 30 equals what? 1 over 2. Agree? Therefore, cosecant of 30 equals what? 2. Yes? All right, cosine of 30 equals square root of 3 over. So secant of 30 equals. Perfect. Tan of 30 equals. There we go. I don't know why I wrote negative. She's tripping. I said I didn't know why I wrote it. And therefore cotangent of 30 equals. Yay, you did 30. Ooh, we survived. Okay. Yes. Are we good with 30, 69? You gotta do 45, 45. We do. Okay. With 45, 45, you have to find your radius.
Square root of 1.
Mm-mm.
Is that 1?
What's 1 plus 1, Andrew?
Oh. I knew that.
Ooh. So for 45, 45, we have 1 squared plus 1 squared equals r squared. So that gives us 2 equals r squared. So r equals the square root of 2. Okay, so for all 45, 45, you have 45, 45, and 90. Its side ratios are gonna be 1 to 1 to the square root of 2.
Can we end this right here? Can we end this?
Why can't we do the sine, cosine, and tangent of it? We're gonna do the 6 trig ratios and we'll be done. It's 1s and 2s, guys. It's 1s and 2s. That's all I'm asking you to do. So 1s and 2s, okay? All right, we're gonna do the sine, cosine, tangent, cosecant, secant, and cotangent of 45 degrees. Are you with me? Okay. So first up, it doesn't matter because the opposites and adjacents are the same. So it doesn't matter if you're using this angle or that angle. Either way, it's still going to be a 1. Oh, look at you. You did it. It was so terrible. What is the cosine of 45? Oh my gosh. What is the tan of 45? 1. Yes, I was wondering why we were stuttering through that. I was a little concerned because it was just 1 divided by 1 and no one was answering me. All right, are we ready to do the other 3? Okay, cosecant, secant, and cotangent. I don't know. I don't know. Who knows? Who knows what I'd be thinking? What again? Square root of 2.
Yeah. Oh, yeah. That's what I'm saying.
Really?
Yeah.
Okay.
Yeah.
I feel like y'all just want to find things to complain about, and that wasn't even hard.
Okay, we're done.
We will let this be our stopping point.
God.
Thank you, Andrew.